this next problem is definitely the hardest of the bunch. They're asking if you have a roller coaster car at point A, that's 30 meters off the ground, how fast is it going to be going at point B, which is 10 meters off the ground? And they gave us the mass of the cart is 100 meters. Oh, 100 kilograms. So how do we do this? Well, the key to this is remembering that the mechanical energy here is equal to the mechanical energy here. Why? Because in the problem they told us that the energy is conserved. So if we can find the mechanical energy at point A, we'll know the mechanical energy at point B, and we can kind of go from there. Let's start out with that. Let's go after that mechanical energy at point A. Well, mechanical energy is potential plus kinetic. So we're actually going to have to go look for both. Now the cart is originally at rest, so the kinetic energy is 0. So not too bad. The mechanical energy is therefore equal to potential energy, which is mass times gravity times height. So our potential energy is 100 times 9.8 times 30. So our potential energy is 29400 joules. That, because we don't have any kinetic energy, is also our mechanical energy. Sorry, this table is loud. So are the planes. If that was our mechanical energy at point A, it has to be the same at point B. So our mechanical energy at point B is also 29400 joules. How does that help us? Well, remember that mechanical energy is equal to potential plus kinetic. We know mechanical. If we also knew potential, we could then find kinetic. If we know the kinetic energy, we can use it to find the velocity. So let's go find that potential energy at point B. So potential energy is mass times gravity times height. And you're like, wait, we just did that. Well, remember, we're doing it for a different height now. So potential energy is 100 times 9.8 times the height is 10. So now our potential energy is down to 9,800 joules. So before it was this, now it's this. Where did it go? Well, in this situation, we have no thermal energy, so all the potential that was lost has turned into kinetic. So we can figure that out by doing mechanical is equal to potential plus kinetic. So our mechanical hasn't changed. It is still 29400 is equal to, all that's left of that in terms of potential is 9,800 plus whatever's turned into kinetic. So our kinetic energy is 19,600 joules. We can use that kinetic energy to now find the velocity. In fact, anytime in energy you're going to be asked to find the velocity, you're going to have to use this equation. mv squared divided by 2. We know our kinetic energy, it's 19600. Our mechanical is 100, velocity squared divided by 2. So you can do 19600 is equal to 100 divided by 2 is 50, v squared. We can divide by 50 on both sides. I'm running out of room. Didn't really plan this very well. And we get 392. So if we want to solve, we're going to take the square root of both sides. So our velocity is 19.8 meters per second. They won't all be as tricky as that. In fact, we're going to go more into this in the next unit, but it's important to start getting a sense of how to do these. Okay. Can you say cookie?
Cookie.
Can you say mama?
Mama.
Can you say onomatopoeia? What you do? What you doing?